In this lesson, we're talking about rational exponents again. So specifically some properties of rational exponents. Remember, that means you've got a power, and that power is a fraction. And what that fraction usually means is some sort of root, like a square root is a 1/2 power, a cube root's a 1/3 power, things like that. So we just have one objective here, and that's simplifying expressions with nth roots and rational exponents. Even though it's one objective, there's lots and stuff in it. So for the picture here, I chose something historical. So speaking of exponents, the modern notation for exponents, a little superscript. The first person to write that down in a book would be the guy on the left there, Rene Descartes, who did lots of stuff, but that's one of the things that he did. However, he only used positive powers, positive and like whole number powers. Then along came this guy, Isaac Newton, a guy who did calculus and lots of stuff in physics and apples. Yeah, so he was the first one to write fractions as exponents. That's that guy, so blame him. Anyway, so not that way, this way. So let's just do a couple of warm-up exercises here. Get us right in the mood of working with exponents again and some square roots, right? So look, on number one, all of these have the same base, w, and they have the same base, and I'm multiplying, I add up the exponents. So this will be w, and 5 minus 8, negative 3 plus the 6 is third power. Okay. Now, whenever I have on number 2 a power to a power, I multiply both of the things inside the parentheses by that power. It's almost like a distributive property. C to the negative 2, and then d to the positive 4. Negative 2 exponent doesn't mean the number's negative. It just means that it's the reciprocal. It needs to go down in the bottom. When it does, it leaves a 1 up on the top. C squared d to the 4th. Right. There we go. All right, on number 3. Number 3, first divide the 20 by the 4. That's just 5, right? And then subtract our exponents on like bases whenever you're dividing. So x, and it's 2 minus 4, so that's a negative 2 power. And on the y power, it's negative 4 minus 1, so negative 5 power. And then finally, the z gets 5 minus 3 is the second power. And we like to have positive exponents, so all the ones that are negative, let's put them down at the bottom. So that's 5z squared over x squared y squared. Yeah, that one needs a box to match the other ones. Right through the answer. Okay. Simplifying radicals. So remember, we can't have perfect squares, perfect square factors inside the radical, because then it's not simplified. One of the easiest ways to do this, to simplify them, is to make factor trees. So there's 2 times 5. Here's a 5 times 3. Since this is a square root, you're looking for pairs of these things. And that pair of factors gets to come out as a 5. Anything that's left behind has to be multiplied together. So that 2 times the 3, that's going to be square root 6. Okay, so all the stuff that we just did right there, we're going to do with rational exponents, fractions. And then on the number 4, we're going to do it with different indices like cube root, fourth root, and things like that. So here, just review with some properties. First one, the multiplication property. Whenever you are multiplying with like bases, you add up the exponents. When you have a power to a power, you multiply the exponents. If there's more than one of the things inside the parentheses, you have to multiply both of the powers on there. And then if you're dividing with like bases, you subtract the exponents, the top minus the bottom. If it ends up being a negative, remember, a negative exponent just means that it's got to go down on the bottom. It means reciprocal. And if it's already negative on the bottom, that means it's got to come back up to the top. And then finally, we hadn't seen this one in those examples, but 0 exponents. If I raise something to the 0 power, it's equal to 1. We'll accept 0 raised to 0 because we're going to say that's undefined. Alright, so all the stuff that we just did there, we're going to do with rational exponents, fractions as exponents. So take a look. Each one of those properties just illustrated with an example with fractions as exponents. So the first one, multiplying with like bases, I add the two exponents. So 5 to the half times 5 to the 3 halves, just add the two fractions, doesn't matter. Sometimes you get a common denominator, sometimes it's already given to you. Anyway, this one simplifies to 5 squared, and you can work that out. Okay, so 3, the next one, number 2, is power to a power, so the power property. So 3 to the 5 halves squared, you multiply those exponents together, and the little 2's will cancel out, and that's 3 to the 5th, and so on. Okay, on number 3, it's still the power property. You're multiplying both of the things on the inside by the same power. So the 16 gets the 1/2, and the 9 gets the 1/2. What's the 1/2 power? It means the same thing as square root. So 16 to the 1/2 power is 4, and 9 to the 1/2 power is 3, and you can go ahead and multiply those out. Okay, number 4 is the negative exponent. It goes down in the bottom. So the 36, the negative 1/2 goes down to the bottom, and then 1/2 means square root, so take square root negative 1/6. Okay, whenever on number 5, like bases, I subtract the exponents. When I subtract the exponents, so sometimes I might have to get a common denominator. On this example, I didn't. So 5 halves minus 1/2. You get 4 squared, simplify it. Okay, and then it's another power property here on number 6. Both of the things on the inside of the parentheses get the 1/3 power, and 1/3 means the same thing as cube root. So 27, the cube root of 27 is 3, and the cube root of 64 is 4. Right? If you say so. So let's try a couple of these. On this first one here, I got 12 to the 1/8 power times 12 to the 5/6 power. And same basis, I add the exponents together. So I keep the 12 the same. Now I just have to add the exponents. I got 1/8 plus 5/6. Well, here's a case where I'm going to have to get a common denominator. Common denominator between 8 and 6 is going to be 24. So let's make that 24 on the bottom. You have to multiply the 8 by 3 to get 24. You have to multiply the 6 by 4, so that makes 20 on the top. So this will simplify as 12 raised to the 23 24th power. That's interesting. Okay, on number 2, I have powers raised to another power. So you give this power to both of these inside, a little bit like a distributive property. So 5 to the 1/3 times 3, 1/3 and the 3 cancel out, that's just 1. And then 7, 1/4 times 3 is 3/4. Nothing more to do there, it's done. Okay, number 3, again, give this exponent to both of the things on the inside there. So this is 2 to the 6 times negative 1/6 is negative 1. And then 4 to the negative 1 power. The negative powers mean reciprocal, so those need to go on the bottom. So this is 1 over 2 times 4, which is 1 over 8. All right, on this one, I think I'm gonna have you. No, let's just do it together. I'll give you one set of practice in just a minute. Okay. So on number 4 here, I do have like bases. I have like basis, so I'm supposed to subtract these exponents, knowing that the top one's the first power. So this is 10 to the 1 minus 2/5. 1 minus 2/5 is 3/5, so that's 10 to the 3/5 power. And you leave it like that, it's done. Okay, now this one's interesting. Notice that they both have the same exponent, same power on the inside of the parentheses. I'm going to use the power property backwards. I'm going to take that 1/4 out. And there's already a 5th that's right there, so this will simplify as 56 over 7 raised to the 5/4 power. Right? So I took the 1/4 out. Warm. And the 5 was already out there. Okay, so I did that because now I can divide the 56 by 7 and just get 8 to the 5/4 power. And then that one's done. All right, so why don't you practice it? I mean, practice on this is going to be essential. So why don't you give it a try on these 3 problems? Okay, thank you. Thank you, pause it, thank you. All right, you're back. You're back with some answers to check. Let's see if these were what you got. So on the first one there, Keep the same base, add up the exponents, 3/4 and a half. You'll have to get a common denominator, and you get 2 to the 5/4. Just leave it like that. Improper fractions as exponents, that's okay. On number 2, again, like bases, dividing, so you subtract the top one being a 1, 1 minus a fourth, we get 3 to the 3/4. Okay, on number 3, using the power property backwards, so take that 1/2 that's on both of the 20 and the 5, take that out, and that makes it 3/2. Go ahead and divide the 20 by the 5, you get 4 to the 3/2 power, and the half power there, remember, means square root. So you're taking the square root of 4, which is 2, and you still have the third power. 2 to the third power is 8. So that concludes the first one. Why don't you come back and check out the next videos, like right down below here.